All right, example 2 in 3.3 is going to ask us to convert the function to vertex form. Okay, it's given in standard form. We're going to use that to complete the square, or we're going to do that by completing the square, sorry, and then verify that the two forms are equivalent, and we'll look at a couple of ways to do that. Okay, so we'll start by, let's just write that out. Okay, and because there is a number in front of the x squared other than 1, we need to start by taking that 4 out of the first two terms. Okay, so we'll just say x squared. Okay, and when you take a 4 out of negative 28, you get negative 7x. Okay, if you ever have something that you want to verify, just go back. As you do that, say 4 times negative 7 equals negative 28, and you know you've done that properly. Okay, not necessarily important here, but sometimes when you're dealing with fractions, it really helps to just kind of multiply that back quickly before you move on. Okay, just to make sure that you don't have the wrong coefficient there. Okay. So we're going to have to take 1/2 of negative 7. So we'll go negative 7 divided by 2. And I don't really want to use decimals here, so I'm not going to. And so I'm just going to have to leave it as negative 7 over 2. Okay. And then to get my other term, I'm going to go 7 over 2, and I'm going to square it. And that's going to give me 49 over 4. Okay. So I'm adding 49 over 4 to the end of that. Then I have to ask myself, well, what have I just done? Okay, I haven't added 49 over 4. I've added 49 over 4 times 4, okay, which actually ends up canceling out the 4. So I've really added 49 here. And to undo that, I'm going to subtract 49. Sorry, I forgot to write my negative 23. I always do that after the space, and I forgot to do that. There it is. So, and then y equals 4 times, and remember, it's this here that goes in with the x when you take the binomial squared. Okay, so it's x minus 7 over 2, okay, and we square that, and you get minus 72. Okay, now that makes perfect sense, right? I mean, it certainly makes sense to have an x-coordinate of your vertex be 7 over 2 or 3.5, right? It doesn't have to be a whole number, and often you're not going to see a whole number. Okay, so there's a couple of ways here to do B, which asks us to verify. Okay, that was A, verify that the two forms are equivalent. Okay, one thing you can do is just work back with it. Okay, so you would just say y equals 4. Okay, and just rewrite those binomials. Remember, when you square a binomial, you just want to write it twice. And then use FOIL. Okay, so you keep the 4 on the outside. Okay, so first terms, that becomes x squared. Okay. Sorry. Try to just erase this one and just use this. First terms becomes x squared, okay, in FOIL, and then the next thing is the O, so outside terms, that's negative 7/2 x. Inside terms, okay, negative 7/2 x. And then last terms, so this one and this one again, okay, and that becomes positive, and negatives cancel, positive 49 over 4, okay, minus 72. That part, put it in the brackets because I do still have that 4 on the outside, right? Okay, so then distribute the 4. And, or maybe before I distribute the 4, you might skip this step or do it, like, in your head or whatever. Sorry, this is not 17. Negative 7 over 2 plus negative 7 over 2 is 14 over 2, or 7. Okay, plus 49 over 4 minus 72. Okay. And when you distribute the 4 now, you're going to get 4x squared minus 28x plus 49 minus 72. Okay, the only thing you can do now is just add those like terms. Okay, and when you add those like terms, you get minus 23. Okay, so what you have here should be the same as what you were given, 4x squared minus 28x minus 23, and it is. Okay, so that's one way to verify it. It's it's just the kind of math that you've been doing for a while that allows you to work back between the two. Okay, another way to do it is to use the graphing calculator or graphing software. So use technology in your book. So here's what I'll do. I will put the function in standard form in there. So 4x squared minus 28x. 4x squared minus 28x minus 23. Okay, and I'm going to put it in the vertex form also. So 4 times, and I will go x minus, and just to be on the safe side, I'm going to put this in brackets, 7 over 2 squared minus 72. Okay, and then when I hit graph, it should graph them both. I'll zoom out a little so you can see it. I mean, that vertex is way down there at a y value of negative 72, right? It doesn't, and it even crosses the y-axis is negative 23. So that's why we have to zoom out so much. You can use these eyes to hide or show the different equations. Okay, the eyes over on the left, maybe you can see where I'm pointing. So if I click the red one right here, it'll hide the red one, and I will be able to see. Well, no, I have to hit graph again, maybe. Okay, for whatever reason, it's not graphing the green one. Okay, 1 second here. I'm going to pause. Okay, yeah, the thing that I had to do there was I just had to put this multiplication here. I guess it just doesn't want you to just use brackets to show multiplication. It made me put that multiplication sign there, so I did, and then it showed the green one. So if we hide the green and show the red, and we just hit graph, you'll just see that you're getting the exact same thing, right? And even if you show them both and you hit graph, it'll do the red one, and then the green right on top, right? So you can see that they're exactly the same function. So that's just another way to verify.